Agilent's low-cost compact N9310A signal generator and N9320B spectrum analyzer deliver all the capability and reliability you expect from Agilent instruments at a price too good to pass up. This demonstration video explains some of the features of the N9310A and N9320B and illustrates how easy it is to use this equipment to make measurements. Until now, you would have to buy a more expensive signal generator to get the features provided by the N9310A. With the N9310A, you can generate RF signals from 9 kHz to 3 GHz and output exact amplitude ranging from -127 dBm to 13 dBm. The SSB phase noise is better than -95 dBc per Hz at 20 kHz offset, and the minimum switching time is less than 10 milliseconds. What does that mean to you? It means more specification margins to make your testing more accurate. The N9310A supports amplitude, frequency, phase, and pulse modulation along with swept signal output. Plus, there's an option that provides additional internal IQ modulation for generating digital signals. For price-sensitive budgets, the N9320B delivers unparalleled functionality. It offers best-in-class performance for a wide range of applications. The N9320B supports 9 kHz to 3 GHz frequency range. The preamp option displays low display average noise level, which means lower signals can be detected. Better than plus 10 dBm third-order intermodulation means better dynamic range performance and impressive sweep speed. Its standard features include a one-button power suite and a power meter function. The tracking generator provides you with a cost-saving means of measuring the frequency response characters without the need for a more expensive network analyzer. The N9320B also supports AM, FM, ASK, and FSK demodulation analysis. Both the N9310A and the N9320B feature a highly evolved, user-friendly interface with a 6.5-inch color display screen, 11-language display, and USB interfaces in front and rear panels. Easy-to-use PC software is provided to help set up a remote operation environment between controller computer and your N9320B using the USB LAN GPIB interface. Quite simply, all of that make the N9310A and the N9320B easy to operate. The optional RF training kit used with the N9310A and N9320B provides basic RF instructional labs. It's a great option for universities and colleges. With professional-grade performance and reliability and very affordable price, the N9310A and N9320B are each ideal for a wide variety of consumers in electronics manufacturing, basic R&D, bench repair, education, and service installation and maintenance. Discover for yourself how valuable the Agilent N9310A low-cost signal generator and N9320B spectrum analyzer can be in meeting your measurement requirements. Thanks for joining us. General purpose operation of the N9310A and N9320B is simple. Here's a quick demo on how to generate a continuous wave with the N9310A and display the signal on the N9320B. To generate a 700 MHz -20 dBm continuous wave signal, select the frequency and amplitude parameters and enable the RF output. The auto-tune key allows you to quickly find the highest level signal across the bandwidth and center the signal on the screen. This feature enhances accuracy and measurement speed. If you want to measure a low level, for example a -110 dBm signal, the N9320B option preamplifier is helpful. It improves the instrument's sensitivity to detect lower-level signals such as spurs and harmonics. Set the frequency, span, reference level, and attenuation as shown. RBW. In the resulting screen, it is still hard to see the signal clearly. To address this, when you enable the preamplifier, the noise floor decreases and the low-level signal is then easily detected. The N9310A generates sweep signals in step or list mode. Step sweep allows you to enter RF output start and stop frequencies and amplitudes, a number of equally spaced steps to dwell upon, and the amount of dwell time at each point. List sweep helps you generate a series of CW signals with specific frequency and amplitude you entered. This demonstration shows how easy it is to generate step swept type signals. First, enter the sweep submenu. Then, set the start and stop frequency, and sweep output amplitude. Finally, set the dwell time at each point and activate the RF output. Now you have the 2 MHz step signals from 960 to 980 MHz with minus 20 dBm amplitude. Use the max hold to keep the sweep signals on the screen, and the peak table function to list the peak signals across the bandwidth. These are typical operations to catch transient signals. This demonstration shows how you can easily configure the N9310A to generate a pulse modulation signal and set the pulse period from 200 microseconds to 2 seconds for use, for example, in EMC test or component test. To generate the pulse modulation signal, set the center frequency and amplitude of the signal generator. Then enter the pulse modulation mode and set the pulse period and pulse width. When you activate the pulse on and RF on, the pulse modulation signal is generated. Set the center frequency, span, and RBW of the N9320B to see the pulse signal on the screen. Switching the N9320B to zero span may help you understand the signal from the viewpoint of time domain. And you can use the delta marker to measure the pulse width of the pulse signal. The Agilent N9310A provides 4 types of analog modulation: amplitude, frequency, phase, and pulse. This demonstration focuses on frequency modulation, which is widely used in broadcasting, wireless electronic device, toy manufacturing, and EMC testing. First, select the carrier frequency and amplitude. Next, select the FM modulation parameters, which include the FM deviation and FM rate. Finally, activate the mode and RF output. Now the FM signal is being generated. You can use the marker table to list the frequency points of interest. If you want to better understand your analog signal, the N9320B option AMA provides the AM and FM demodulation metrics, including carrier power, modulation rate, AM depth, FM deviation, synad, and carrier frequency offset. The Agilent N9310A signal generator has an optional broadband IQ modulator and is able to generate digital signals in conjunction with an external IQ source. The output signal can be measured with the N9320B spectrum analyzer. In this demonstration, two 33250A arbitrary waveform generators are used to generate digital baseband IQ signals, and these IQ signals are input into the N9310A to produce RF signals. At first, we generate a GMSK signal, which is widely used in GSM communication systems. We measure the channel power or occupied band power with the N9320B built-in one-button power suite, which helps you finish the test setup simply by pressing one button. The power suite not only shortens the learning curve, but also helps ensure the accuracy of the test setup. Now we change the configuration to produce FSK signal. The N9320B option DMA supports the demodulation of ASK and FSK signals and also provides readouts for the baseband symbols, RF waveforms, ASK-FSK errors, and eye diagrams. The digital signal generation and demodulation can be widely used for manufacturing a variety of wireless products such as cordless phones, two-way radios, RFIDs, and wireless mice. The optional tracking generator adds a new dimension of power to the N9320B spectrum analyzer. This demonstration shows how the tracking generator lets you measure the insertion loss of a filter. Turn on the tracking generator mode and set the start and stop frequencies. Set the output power to -10 dBm. Reduce the resolution bandwidth to increase measurement sensitivity and smooth the noise. Activate the tracking peak to correct the frequency offset between the output frequency of the tracking generator and the input frequency of the analyzer. Connect the cable from the tracking generator output to the analyzer input. Next, store the frequency response in Trace 4 and normalize to eliminate the effect of the test environment. Reconnect the filter to the analyzer and change the normalized reference position. The marker readout displays the insertion loss of the filter at specific frequencies. The N9320B also provides a straightforward way to measure the 3 dB bandwidth of your DUT with just one button press. To learn more about RF circuit design, circuit characterization, and communication systems, Agilent offers the N9320B TR1 RF Training Kit option, which can be used with the N9310A and N9320B. This out-of-box training tool includes two boards. One acts as a transmitter circuit, and the other one serves as a receiver circuit. The major RF components on each board can be used as separate, standalone components. Using Agilent's flexible RF education solution is convenient, time-saving, and cost-effective. This solution uses an N9310A RF signal generator, N9320B RF spectrum analyzer, a transmitter and receiver unit, and the RF training software. The RF signal generator generates an input signal to the transmitter unit, and the spectrum analyzer measures the output signal of receiver units. Using just the transmitter unit, we input a 50 MHz signal. We have an onboard 818 MHz frequency synthesizer, and the board's output connection is to a spectrum analyzer where we see an 818 MHz signal. Now let's take this step by step down the transmitter board. First, we look at the output of the mixer. We can see on the spectrum analyzer that there is an 868 MHz signal at the output of the mixer. However, there are many byproduct signals. Consequently, we have to filter out the unwanted signals. The next step is to move the analyzer to the output of the bandpass filter, and we can see it blocks many of the unwanted signals. However, the power of the 868 MHz signal is minus 29 dBm. Since this power level is too low to transmit over the air, we need to amplify it. We move the spectrum analyzer to the power amplifier section and can then see the 868 MHz signal at minus 19 dBm level. But there are other signals present, and we are not allowed to transmit the signal over the air. At this stage, we need to do a final filtering to remove the unwanted signals. At last, we connect the antenna to the output of the transmit unit and measure the output of the receiver unit. This successfully recovers the transmitted 50 MHz signal and completes our basic demonstration of one of the system's capabilities. Agilent's low-cost compact N9310A signal generators and N9320B spectrum analyzers deliver all the capability and reliability you expect from Agilent instruments at a price too good to pass up. Visit our website for a closer look at how valuable the N9310A signal generator and N9320B spectrum analyzer can be in meeting your measurement requirements.